and midpoints. And this stuff should be familiar, especially if you look at the fact that there's a triangle here. So let's take a look and see distance between 2 points. And this is an interesting formula that they give you. If I can make it a little bigger, there we go. And it shows that if you want to know the distance between 2 points, you subtract 1 point from the other and take the absolute value. So in other words, you kind of count between the 2 points and see how far apart they are. So like here, if they're talking about the distance between point D and F, you have to be able to say, okay, this is -2 and this one is 5. So, if they're like 5 minus and -2 is really what they're saying, then you'd have 7. Distance is 7. Okay, so you just got to be paying attention enough that you can, that you can realize the distance. All right, let's go to the. Okay, so we're going to talk about this finding distance between 2 points just on a graph. Just from the coordinates of the points. And this is very much related to the Pythagorean theorem, as you see up here. If you have, this point here, point A, and point B, they're going to be x and y and x and y. And if you see how you can put, I go back to my pointer, you see the distance here. This is the difference in the y's. The y minus the other y, and then this one will be the difference in the x's, the one x minus the other x. And so you're going to have distances, and that gives you the sides of the right triangle for the Pythagorean theorem. So like we'll do an easy one here. If this is 3 and if this is 4, then you should be able to figure out that the distance here is 5. And the way it works is like they're showing here. They're showing CB, that's where I have the 4 squared, and AC, that's the 3 squared. That will equal AB, which is the distance you're trying to find. That would actually be a 5 instead of a C. And that's what they're showing here, is that you subtract the x from the other x and the y from the other y, and then take the absolute value, which you don't really need to take the absolute value because you're going to square it anyway. And then add it together. You have to take the square root of both sides, and that's how you get the distance. So the one way they show it is you could set up a right triangle on a graph and look at your distance down, look at your distance over. But in a minute, you're going to get to this distance formula down here, and it's going to show you how to do it just straight from the formula, which you kind of already see right down there. So just use the x and y of each one, plug it in, and that's how it works, because you're looking at the differences in the y's and the differences in the x's, and it's just a right triangle. And now on to part 2, since I got cut off. And that is then the distance formula, and it's just based on what you saw above, which is the Pythagorean theorem. So really, there's no magic here. If you want to know the distance between 2 points, you just take the differences between the x's in each point and the y's in each point, square them and add them together, and then take the square root, and you will have the distance. Because it's basically, like if I do this, it's basically like you're just making a right triangle and saying, what's the distance here, what's the distance there. You add those distances together after you square them, take the square root. That's it. That's all there is to it. Hopefully that's pretty straightforward. All right, let's keep going down. Got to go back from the eraser. There we go. Okay. And then they show you some stuff here on page 26. They just show you how some work, and this is the typical thing here. You'll get a couple points and, you just say, let's see, 8 and -5. I'm guessing those are 13. Let's see if I can do this one right. 13 apart. And 6 and -4. I'm pretty sure that those are 10 apart. So that's 100. And I think 13 and 13 is 169. So you add those together, and that's where they're getting this square root of 269 thing. And then that apparently is 16.4. There you go. Plain as day. Hopefully that's making good sense for you. Let's clear that off. All right, let's go to the next. Going back to the segments, talks about how to find the midpoint between 2 points. And it says you just add the 2 points together and divide in half, and that will be the midpoint. And it works. Here, I'll give you a very easy example. We'll use 1 and 3. And if you add those two together, excuse me, you get 4 divided by 2, you get 2, which, guess what? That would be right in the middle. But it also works even if you have a negative number, because 3 and -1 added together gives you 2, and 2 divided by 2 is 1. So that means the midpoint should be 1. And if you look, distance from 3 to 1, there's 2 from 3 to 1, 3, 2, 1, and then -1 up to 1, you go -1, 0, 1. So it does work even with negatives. And so next, of course, we'll find out how do you get the midpoint on a graph. And it's similar. It's actually easier than finding the distance, but we'll get to that in just a minute. And now on to part 3, cut off again. That's what happens when you use your cell phone as a hotspot. Yeah, so right now I'm in a random spot recording a video, probably in an area of a building I'm not supposed to be in, but as long as nobody finds me, it'll be okay, right? Okay, so this is the midpoint when you're on the coordinate plane. You're going to have 2 points. You're going to have a point here with coordinates and a point here with coordinates, x's and y's. And you notice you take, from each point, you take the x's and add them together, divide by 2. Take the y's, add them together, divide by 2. Now for this, what you'll end up with, hopefully you'll see, is you will end up with an ordered pair. You'll end up with a new x and a new y, and that will be the exact coordinate of the midpoint. Okay, makes sense? Let's move down and see if I don't get cut off. So here is the part about the midpoint on coordinate plane, just making sure you find it. Add the x's together, divide by 2, add the y's together, divide by 2, and you're going to get that coordinate. You're going to get a point, an x, y. And if I clear this off, then I can show you an example of this. Oh, I always forget to go back to that. There we go. So if we look at these couple examples here on page 28, what you're really doing is you're saying, all right, I have to take the 5 and the -4. So 5 and -4, add them together. That would be 1 divided by 2. That's how they got the 1/2. The other one, the 12 and the 8, that would be 20. Divide that by 2, you get 10. So that midpoint is right there, 1/2, 10. The other one, you have -8 and 5. You get -3 out of that. Divide it in half, you get -1/2. -2 and 1, you get -1. Divide by 2, -1/2. And that's all there is to that. Now I'm going to give you a little more on the next part when they say, okay, I'm going to give you a point and an end point. And how do you find the other point? So that's coming down here. They're going to say that you have, you know, like here it says we have this -1, 2 is the midpoint, and JL, and L has the coordinates of -3, 5. And I do it differently. I don't go, because what they're doing is they're taking what you know here. We know the one part of the one coordinate, we don't know the other one. Divided by 2 equals -1. But the way I'm doing it is I draw it and write it out and do it as a line, and you'll see that in just a minute. I think this is part 4. I'm not sure. I mean, it'll all look good to you. I'll put it all together in one video at the end, but I keep getting bumped off. So again, you know, if you use the midpoint formula, you know, here's my -8, 6. Here in the middle is -5, 10. You know, and they go through this long thing and to say, you know, how do you find out what this other point is? Because if I know this one's here and this one's here, but that's the midpoint, you know, to me, I look at it and I do it visually, because I say, if my x is -8 to -5, that's a +3. I'm going a +3 to get from here to there. If I go another +3, I'm going to be at -2, which is what it shows right there. Same thing, if I'm going here from 6 to 10, and that's the midpoint, that's a +4. I go another 4, and that's how I get to 14. This step 2 shows you how they do it, but I think there's an easier way. So there you go. It's not too, I think if you write it down, draw it out, it should be pretty easy to do. So I keep getting bumped off of these videos, and I have to go back in and redo parts. So I'm sorry if there's overlap, or if this, I know this video is getting longer than I wanted, but I'm trying to fill in all these holes. So this one is about using algebra to find measures. And so basically what they're saying on this one is, if you know that Q is the midpoint here, you know, then each of these parts have to be equal to each other. So you can put 9y minus 2 equal to 14 plus 5y, and you can solve it to figure out what y is, and then you can put that in to figure out the size of each one. And no matter where you put it, you should get the same number. You know, you should be able to get 34 for each part of that. So that's what they're going after for that. And again, down here on these guided practice ones, you know, it's saying, you know, y is the midpoint, xz and xy. And, you know, they say that this one is 2x minus 3, this one is 27 minus 4x. And set them equal to each other. If you're not sure, it helps me a lot to draw it out. And I think that's what I have in the next part of the video, is drawing it out. So there you go. Part 17. So again, what I was trying to say, I don't know if it doesn't like the pen or what. So I have this x, y, z thing. And xy, that's the 2x minus 3 and 27 minus 4x. And so then those have to equal each other because of the midpoint thing. So then you just figure it out from there. That's all it is. The next part talks about segment bisector. So let's see here. Oh, that must be the end of the page. Segment bisector. It says any segment, line, or plane that intersects a segment at its midpoint is called a segment bisector. All right, so I mean, should make sense, you know, and it shows you here that M, right there, M is the midpoint of PQ. That's this right here. So M is the midpoint, all right? Plane A goes right through M, so it's a segment bisector. What else? MJ. So this segment here, MJ, is a segment bisector. KM, this line goes right through M. That's a segment bisector. point M itself is a bisector. Okay, they all bisect, not dissect. No disgusting science biology stuff here. Just bisecting. So there you go. Let's pause that for a second. So anyway, I think the assignment goes up through 56. There's really nothing that I haven't covered in there, and you have the examples in the book to look back through. That's pretty good. The lesson's pretty straightforward. We might look at this spreadsheet thing when I get back. I'm not sure how important it is. We'll decide, but that'll become. Then we'll do some stuff with bisecting. So make sure you ask questions, and then we'll see where things are on Thursday. Have a good time.